Hello everyone, my name is Alvaro, and in this video I will be covering another problem from the blind Leetcode 75 problem list. Today we will be doing problem 191, which is called number of 1 bits, and this is one of the easiest binary problems in the list, if not the easiest, so this should be a short video. So let's read the problem statement. Write a function that takes an unsigned integer and returns the number of 1 bits it has, also known as the Hamming weight. We're going to ignore these notes because they're in Java, and we have the following input. Keep in mind that whenever we get the input, it's just going to be a regular number, like let's say, I don't know, 63. Let's say that, right? So it's not going to look like this, but the output here is 3 because the input binary string has this. And for those of you, right, that do not know binary or have forgotten a little bit, all that you need to keep in mind is that each position right here represents a power of 2. This one right here is the power of 2 to the 0, 2 to the 1, 2 to the second power, 2 to the third power, 2 to the fourth, 2 to the fifth, and so on until we get to 2 to the 31. Because the constraint here is that the input must be a binary string of length 32. So how do you know what number this is in decimal? Well, this would be 2 to the 0, which is 1, times 1, plus 2 to the second, times 1, plus 2 to the third, times 0. Oh, sorry, I said 2 to the third, oops, sorry. So 2 to the 0 power, which is 1, times 1, 2 to the first power, which is 1, times 1, 2 to the first power, which is 2, plus 1, sorry, times 1, and then 2 to the second power times 0, and then 2 to the third power times 1. So pretty much, if there is a 1, we multiply whatever number it represents, and if there's a 0, then multiply by 0. And that's just how we're going to be doing it. And we start from the right. So this number right here represents an 11. And the idea is that we're given the decimal number, even though here it says this right here, when I tested this problem, n is actually represented by a number. So the idea is, okay, if we're given this number right here, how do we get the number of 1 bits that it has? So I guess a way to do it is to simply convert the number into binary. And how do we do that? How do we get 11 to go back to this representation? Well, very easy. The main idea here is to just check what the remainder of this number, whenever we divide it by 2, what is that? So 11 mod 2 is 1, because whenever we divide 11 over 2, if we only want to get integers, that is, the remainder will be 1. And after that, all that we do is we just divide it by 2, and we set it up as the floor, so we're doing an integer division. Here, the same thing, and then 5 divided by 2 is 2, using integer division. This is a 0, like that, and whenever we hit a 0, then that's when we stop. And if you notice, if we read from the bottom all the way up, that's this number right here. And we can just simply ignore all the zeros. So that's what we're going to be doing. We're pretty much going to be counting whether the current number, mod 2, is equal to 1. If that is the case, we increase the count, which is the number that we want to return. And then we perform an integer division over 2. And we keep repeating this until the number that we're currently dealing with is equal to 0. So let's get to it. So while the number is greater than 0, what we have to say is, okay, if n mod 2 is equal to 1, then we increase count. Then no matter what, we perform integer division on it. And then we simply return the count. And this should work. I've tested this problem before, and it eventually gave me like a top percentile answer. As usual, you know, like the runtimes are a little bit inconsistent, but eventually it gets there. Yeah, that's good enough. So what is the runtime of this problem? Well, I guess it depends on what you want to use, but the main idea here is that it will be O of 1 because we're using constant space. However, if we want to take into account how many bits the number itself has, if we count that as a distance that's not constant, um, which technically it is because it's 32 at max, so it will never be greater than 32. But suppose, we are counting like very, very small operations. Our algorithm, right, will perform a couple more operations if we're doing, let's say, number 11. And then if we're doing number, let's say, I don't know, this number right here. I hope it's smaller than 2 to the 32nd, but I'm pretty sure it is. Um, so obviously, like, this will divide by 2 like several more times than this, right? So if you want to get technical and you want to define the number of bits that the number has, that number n has, then I guess you could say that the runtime is big O of n. But for all intents and purposes, I would say that the runtime is big O of 1. Similarly, the space is big O of 1 because we're only using one variable, and that's always going to be constant. And that's pretty much it. That's the video. It was a simple one. I hope you enjoyed it. And if you struggled a bit, make sure to review your binary numbers because there are a couple of binary problems in this list. You probably won't get asked these questions very often, but nonetheless, it's still good to know. But yeah, so I hope you enjoyed the video. Make sure to hit like and all that. And thank you very much for watching. See you in the next one. Bye-bye.